Do you ever find yourself in a meeting or in a workshop wondering if you've missed a tremendous opportunity? This was the situation I found myself in a workshop I was running in Scotland 9 years ago. Over the last 20 years, I've worked with many global organisations to improve their operational performance. And the last 10 years, I've spent focused on KPIs and performance measurement. It was in this role that I found myself leading this workshop for one of the UK's largest pension providers. We were discussing the KPIs that would help them with their business and ensure that they retained as many customers as possible. The business model is quite simple. You need to sell pensions and make sure that that person stays with you for their entire lifetime. So retaining custom is very, very important. We were talking about what would be the best measures to do this. And one of the guys in the workshop said, why don't we measure the likelihood of a customer leaving? There was a short pause while the people in the workshop thought about this. And then the guy who was in charge of management reporting and KPIs chuckled to himself and said, well, I'm not sure we can read the mind of our customers. He paused to laugh at his own joke. And then he went on to say, but what we can measure are the number of customers that left last week and last month. It's practically the same thing. So why don't we just report that? And that was when I realized we've probably just missed a huge opportunity here. We had an impossible measure. Can you measure what's on a customer's mind before they do something? That question set in motion a series of other questions that I posed to myself. Firstly, is it possible to come up with a method, a repeatable way of measuring the impossible? Secondly, if you could come up with a way of doing that, could you apply it in any industry, in any sector? And then finally, the question that today's talk is about is, can you really measure anything? Answering these questions led me to set up my business, Made to Measure KPIs, to write my first book, KPI Checklists, and also to discover that an old Greek guy, Sesame Street, and hungry blue whales hold the key to measuring just about anything. So today we're going to talk about an old Greek guy, Sesame Street, and hungry blue whales. So let's talk about the old Greek guy first. Eratosthenes lived 2,200 years ago in Alexandria, and he was an amazing guy. He was an incredibly talented astronomer, historian, geographer, philosopher, poet, theatre critic, mathematician, and he also, as his day job, was chief librarian to the Library of Alexandria. Two of his skills came together in a really interesting way. Doing his job as the librarian of Alexandria, he noticed a papyrus that mentioned something unusual. On June the 21st, at midday every year, in a city in southern Egypt called Syene, there were no shadows. At that exact time, the sun shone directly down a well, and you could see the bottom. And Eratosthenes asked himself a question. At that time, on that day, when there are no shadows in Syene, would there be a shadow in Alexandria? He decided to measure it, and he found that when there were no shadows in Syene, there were shadows in Alexandria, and they were 7.2 degrees. Clearly, Eratosthenes had an idea here, and he managed to show that 7.2 degrees is 1/50th of a full circumference. He decided to measure the distance from Alexandria to Syene, and he did this by paying a man to walk and pace the distance. He found it to be 5,000 stadia, which was the unit of measure. That's exactly 800 kilometers. And using these two facts, he managed to calculate that the Earth's circumference was 250,000 stadia, or 40,000 kilometers. Now, we know from our modern measurement that he was just 160 kilometers away from the correct answer. So just 0.4% away from the correct answer. So Eratosthenes' impossible measure 2,200 years ago was to work out the circumference of the Earth using only a stick, basic geometry, and a man pacing between two cities. He then went on to work out the tilt of the Earth and also the distance between the Earth and the Moon and the Earth and the Sun. Unfortunately, those last two calculations have been lost in time. Interestingly, Eratosthenes was called Beta by all of his contemporaries because he was excellent at many things, but best at none of them. I think it just goes to show how hard it is to impress some people. The reason I tell this story is I regularly see clients who are very, very enthusiastic to start measuring things from scratch, to create their own measures. But what I've found is very often their assumption that they are unique is not true. To give you one practical example, I worked with a company that was unique. They invented a process, they owned the technology, they made their own machines. They had a problem. They had a problem with moisture in their product. This moisture could cause the product to stick together and rot. Their method of measuring moisture took 7 hours. You had to cut the product up, weigh it, dry it, weigh it again. They needed an instant measurement, and they were stumped. They were trying all the different ways they could think of to measure moisture. I had the good fortune to work with them. I'd also worked in another industry, the paper industry, and knew that this problem had already been solved. Within a week, we had the measurement equipment on the line, successfully measuring, and within a month, we had it on all 32 production lines. It was instant, it was non-contact, it was extremely accurate. So rather than having to solve this problem again, we simply used something that was already in existence in a multi-million-pound industry elsewhere. So the lesson from the old Greek guy and from my client in manufacturing is the first question you should ask yourself when facing the impossible is, has it or something very similar been measured before? Very often the challenge isn't coming up with a new measurement technique, it's simply rediscovering it. Just to give you some examples of some more unusual things that have been measured, I would recommend that you visit a website for the Ig Nobel Prize. They give prizes for eccentric and unusual measurement. Here's 3 examples of things that really have been measured by scientists. The first is body fat composition in Spanish soccer referees from the Scholarly Journal of Measurement and Control. From the Journal of Neurophysiology, someone has actually electrically monitored the brain activity of locusts whilst watching selected episodes from the movie Star Wars. And someone else has, from the Journal of Forensic and Legal Medicine, determined by experiment whether it is better to be hit over the head with an empty or full beer bottle. So I would just reiterate, rather than reinventing measures, try rediscovering it first. So I talked about our old Greek guy. Next, we're going to draw inspiration from Sesame Street. Who here has heard of Sesame Street? Okay, so it looks like it's popular here. For those of you who've not come across Sesame Street, it's an educational children's program aimed at preschool children, so children ages 1 to 4. It's intended to be educational, and it was designed in the early 1970s. The makers wanted it to reach as wide an audience as possible, because research had shown that for a child to learn, they must be interested. Now that seems like a very well understood concept now, but it was revolutionary at the time. So the makers had to make the program as engaging as possible to the viewers. They realized that the program needs to hold attention, that the young audience lose attention very, very quickly, and finally, you can't just ask a one-year-old what they think of a program. So their impossible measure was what makes a TV program interesting to preschool children. And they took a radical new approach. They used research to help them make the decisions on the program, and they also broke the program down into chunks, almost like adverts. They were individual scenes, so they could see which part of the program worked and which bit didn't. And the key to it was they decided to measure attention, whether the child was paying attention or not. And they did this by taking 72 children from Amherst, Massachusetts, and they specially built a lab. It was 12 foot by 12 foot, with a TV in the corner and plenty of toys. They would settle the parent and child into the laboratory, give them a few minutes to play, then they would give the parent a questionnaire, just to keep them busy, to make sure they didn't interfere with the experiment. And 5 minutes in, they would start to play the program. Researchers videoed this, and then after the experiment, they would go through and look to see where the child's attention was, and when it was lost or gained on the TV, they would note why it was lost or gained. They had 31 attributes: a new character appearing, a change in the sound, an animal appearing, and so on. So they managed to break down the entire program into chunks. They understood what gained a child's attention and what lost it. I guess the key question is, did it work? Was the research effective? Well, a survey in 1996 showed that 95% of American preschoolers had watched the program. It's still running in 140 different countries. It's won 159 Emmy and 8 Grammy Awards. So I think it's safe to say, yes, the measurement and design approach was extremely successful. So what can we learn from this? Well, the key to the successful measurement was the observable consequence of a child being interested. And that observable consequence was, if they are interested, they will look at something, in this case, the television. If they're not interested, they'll look at something more interesting, in this case, toys. Although I found running workshops, for grown-ups, it tends to be BlackBerries and iPhones. So Sesame Street taught us the second crucial question. What are the observable consequences of the thing we are interested in measuring? If you can't measure it directly, what else happens at the same time? I'll give you another example from a completely different field. Scientists have recently discovered another planet in our solar system, and yet they've never seen it. Whether it's the 9th or 10th planet, depends on whether you think Pluto's a planet. It's huge. It's 10 times the size of the Earth. So if we haven't seen it, how do we know it's there? Well, if you have a large mass in the solar system, it affects the orbits of the other things in the solar system. So scientists have analysed the movement of all the planets and objects that we can see and know that that movement can only be explained by another body in the system. And from that, we know that it's 10 times the size of the Earth, and it's got an average distance from the Sun of 56 billion miles. So those two questions are very powerful. Check to see if it's been measured before. If it hasn't been measured before, look at the observable consequences. There are situations where those two questions won't quite do it. So we come on to our third question, which is inspired by a Nobel Prize-winning physicist, piano tuners, and the hungry blue whale that I mentioned at the start. Enrico Fermi was a genius. He studied physics at age 14, won the Nobel Prize for theoretical physics on neutron radiation, and he used to regularly pose a question to his students, which was, can you give me the population of Chicago? Sorry, can you give me the number of piano tuners in Chicago if I just give you the population of Chicago? They used to look at him blankly, and then he would explain to them how to do it. He would say, if there's 3 million people in Chicago, let's assume an average house has 4 people in it. That makes 750,000 people. If we say 1 in 5 has a piano, that's 150,000 pianos. Now, if a piano tuner can tune 4 pianos in a day, works 5 days a week, 50 weeks of the year, then a piano tuner can tune 1,000 pianos in a year. So it's safe to say there's probably about 150 piano tuners in the Chicago area. We certainly know that there wouldn't be 15, and we certainly know that there wouldn't be 1,500. Now, this is called a Fermi decomposition. And the question we need to ask is, can we break down our impossible measure into its constituent parts? Now, let's come back to the hungry blue whale that I mentioned right at the start. I'm a huge fan of David Attenborough and his wildlife programs. And I watched an amazing episode where they filmed the blue whale, and they had an interview with the cameraman afterwards. It took him 2 years to get 7 minutes of clear film of the blue whale. And yet, in the program, they explained how much a blue whale ate. And I was curious, how on earth, if it takes the most wildlife cameraman in the world 2 years to get 7 minutes of footage, how do they know how much it eats? And of course, the answer is a Fermi decomposition. They took the smaller cousin of the blue whale, which you can keep in captivity. They could measure how much they eat and whether they're growing or not growing. You could work out the energy requirement of the whale per kilogram. You can estimate the length and circumference of the whale. And you can also estimate the energy content of their food. And from this, you can calculate how much a blue whale would eat, more or less. Just in case you're wondering the answer, it's 432 tons of the tiny sea creatures called krill each year. Now, I've kind of rushed through this last bit because I know we're short on time, but I'd like to bring this right the way back to what we discussed at the start, the financial services customer that I was working with and their predictive measure of whether a customer was going to leave. Well, it turns out, if you looked closely at their process, there was something that all the customers who left and went to another company had in common. They all called in for a valuation before they left. Now, it makes sense, if you understand how pensions work. To go to another company, they needed to know how much the transfer value of their pension was and how much pension they would get with another company. My client had automated this process a few years ago. So when you rang up, you would get through to a computer. You knew who you were, and the computer would tell you the value without ever talking to a human. Once we understood this, we changed it so that the individuals were put through to a highly trained customer service representative who gave them the measure and politely asked them why it was they were thinking of leaving, or if they were leaving, and offered them options to make sure that they could retain them as a customer. So in that case, question number 2, what are the observable consequences, was key. And it enabled this organization to predict and anticipate and change the outcome of the customer's actions before they left. So, just like our Sesame Street researchers, they watched what else happened at the same time as the thing we're interested in. So, to summarize, I do believe that with the help of questions inspired by an old Greek guy, Sesame Street, and a hungry blue whale, yes, it is possible to measure anything. Thank you very much.
We still have questions.
Oh, certainly, yes, sorry.
Thank you very much, Bernie. Thank you very much.
Do we have time for questions?
Yeah, we'll take two questions. Any questions? Great. Okay, great. Thank you very much, Bernie.
Thank you.
Thank you very much.